this video, I'm going to be talking about how we can find lines that are perpendicular to a given line. So, as an example question, I could be asked to find a line perpendicular to the line y equals 5x. Now, it should not surprise you that there are infinite number of answers here. I could go boring. I could just go with y is negative a fifth of x. I know that this one will be perpendicular to y equals 5x because the gradients are negative reciprocals of each other. The negative reciprocal of 5 is negative a fifth. But of course, I could also have a completely different y-intercept. So I could have y equals negative a fifth x plus 3, because that's still the negative reciprocal of the gradient, which is all that's important for the lines to be perpendicular. The y-intercept doesn't matter. So I could also have y equals negative a fifth x minus a quarter. I could have y equals negative a fifth x plus root 2. I could y equals negative a fifth x plus pi. I could have y equals negative a fifth x plus c, where c is just some number. Of course, I could also rewrite these in some other form. So I could take this y equals negative a fifth x plus 3, add a fifth x to both sides, and I could write it in this form instead. Y plus a fifth x equals 3. So this would still be a line that's perpendicular to y equals 5x. It's just not immediately obvious that it is because it's written in a different form. It's not in the form y equals mx plus c. Similarly, if I times everything by 5, I get 5y plus x equals 15. Now this is a nice form because it doesn't have any fractions involved. But of course it does have the disadvantage that it's not in the form y equals mx plus c. So we can't immediately find the gradient. We'd have to rearrange it first. But anyway, all of these would be perfectly valid answers to find a line perpendicular to y equals 5x. So in questions, we're often slightly more specific than that. We'll say find a line perpendicular to y equals 5x that goes through 0, 3. Because there will be a unique line that is perpendicular to the y equals 5x that goes through a given coordinate. Now I know from my work on the last slide that my gradient is going to have to be negative a fifth. So I know that it's going to be y equals negative a fifth x plus something. I just need to work out what that something is. And I can do that by substituting the equation into this, substituting the coordinate into this equation. So when x is 0, y is 3, which means 3 is equal to negative a fifth times 0 plus c. But negative a fifth times 0 is just 0. So this equation is the same as 3 equals c, which means that y is negative a fifth x plus 3. I have just used this equation to find what c is, and then I can put it into that form. Now, of course, this shouldn't surprise us because the coordinate 0, 3 is the y-intercept, so I know that my y-intercept should have been 3. Okay, next one, to find a line perpendicular to y equals 5x that goes through the coordinate 1, 3. Well, I know that it's going to have to be perpendicular to y equals 5x. So I know that my gradient is going to have to be the negative reciprocal of 5, which is negative a fifth. So y is going to be negative a fifth x plus c. I can then substitute in this coordinate, x equals 1, y equals 3. Then rearrange to get c on its own. To do that, I have to add, well, a fifth times 1 is just a fifth. So I have to add a fifth to both sides. I get c is 3 and a fifth. Of course, I could write that in a nicer way. I could write it as an improper fraction, but I'm going to choose not to. I'm just going to leave it as 3 and a fifth, which means that y is negative a fifth x plus 3 and 1/5. So now I want to find a line perpendicular to y equals 5x that goes through 3, 0. So I know that because it's parallel to y equals 5x, it's going to have to be of the form, that's coming in the wrong order, never mind, y equals negative a fifth x plus c, because that has to be the negative reciprocal as my gradient. I can then substitute in the coordinate 3, 0, so x equals 3, y equals 0. 0 is negative a fifth times 3 plus c. Well, a fifth times 3 is 3/5. So if I add 3/5 to both sides, c has to be 3/5, which means that y is negative f of x plus 3/5. That would be my equation. And as a final example, to find a line perpendicular to y equals 5x that goes through coordinate 3p, I again know that it's going to have to be of the form y equals negative f of x plus c, because my gradient has to be the negative reciprocal of 5. So it's just the c I'm trying to find, and I'm going to find c in terms of p in this case. I'm going to substitute in 3 and p. So x equals 3, y equals p. We get p is negative a fifth times 3 plus c. If I add, well again, a fifth times 3 is still 3/5, so I need to add 3/5 to both sides. Get that c is equal to p plus 3/5. So my equation is y is negative f of x plus p plus 3/5. So again, notice that this form here with p equals 0 would give me this equation. So this is just a special case of what's going on over here. Okay, the key points from this video. If we know the gradient of a line and one point on the line, we can substitute into y equals mx plus c to find the equation of the line. In this case, we were using this fact for perpendicular lines. So we worked out the gradient of the line by using the fact that it was the negative reciprocal of the gradient of the original line, and then we substituted in the values from one point.